Good morning. You are welcome to your chemistry lab. Today we are going to make an experience about how to separate mixtures. It is very important to learn the different methods for separation of mixtures. They are very usually in our daily lives. Today we have here four substances. First we have some glass spheres. Okay, as you can observe, they are the physics test, they are solid. Okay. Next, we have the common salt of sodium chloride, is this white color powder, crystalline. Okay. Here is another drop of sulfur. This is yellow color powder. Okay, not solid in water. And finally, we have a sample of pure iodine. Iodine is a halogen, as you can remember. It belongs to the 7A family. And don't forget that the elements of halogens are very aggressive. And they are separated, but now I am going to mix all of them. First, I am going to pass the glass spheres to a beaker. Next, the salt, the sulfur powder, and finally the iodine particles. Okay. Let's go to mix perfectly to incorporate all the ingredients in our mixture. And as can you observe now, they are very complicated to separate. Imagine you are not going to take every particle of sulfur to separate them, or every particle or every crystal of sodium chloride, but it's very important to learn about the methods of separation of mixtures. First, to perform the separation, I'm going to put a portion of water, pure water. I am going to stir. Why do you think that is the component that will be solved in water? Sulfur, the glass, the salt, or iodine? Okay. Observe, the liquid portion is very clear. Let's go to pass the first separating method. This is a filter paper that will be used for make the first separation. Let's go to going by the middle part. I'm going to pass the liquid portion of the mixture. This first method is called filtration. As you can observe in the surface of the liquid here, the filter paper is able to capture, to retain all the sulfur particles. Okay. And as you can observe also, the liquid portion is very clear. in the beaker, we have now the particles of glass and the iodine particles that we are going to separate after. Okay. Next, I am taking the liquid portion, the solid portion, sorry. You can observe violet vapors, which correspond to the iodine that is sublimating in this experience. When iodine sublimates, it's going to produce very intense violet color vapors, as you can observe in the container, in the flask. In the beaker, sorry. Iodine is sublimating and it's leaving alone the glass particles in the bottom of the beaker. Now I am going to change. I'm going to put here the filtrate that we obtained in the first step. If I remove the cover, you can observe here the iodine particles. But in the bottom, still the glass particles separated from all the mixture. So I have evaporated here sulfur by filtration, the glass particles by decantation, and iodine by sublimation. So the only missing method is this, it's filtration and evaporation, which is going to take a little bit of time. I'm evaporating all the water in which the salt was dissolved. So you can observe here inside the beaker how the sodium chloride is separated from the mixture. And finally, I got to separate all the ingredients of the mixture. Sulfur, pure sulfur, glass particles. Here is iodine, that you can appreciate a brown color substance here, and sodium chloride, okay? And these are very important methods for separating mixtures, okay? Let's start here. Pay attention, please. So, four of the most common methods for separating mixture is filtration, decantation, sublimation, and evaporation. Okay. In conclusion, in this experience, lab experience, we have separated sodium chloride. Okay, the substance. Sodium chloride was separated by filtration and evaporation. Sulfur was separated just for filtration only. Iodine was separated by sublimation. And glass by decantation. Okay. I hope you liked this lab experience, and thank you very much for your support and for your collaboration. Bye.